Okay, so let's take a look at page 38. This topic is called the rational expression. Okay, so we'll go over what's inside here. First, we'll be talking about restrictions. Okay, restriction means something you cannot do in a rational expression. Rational means it's a fraction. So you can see you have a lot of fractions, but then instead of just having numbers, we have now variables in the numerator and denominator. Okay, so when you have these things, right, then we call them rational expressions. And when you have variables, then you get some restriction on it. We'll be talking about what kind of restriction we put, okay? And then next part is simplifying rational expression. So just look at the first one, right? 8/10. We can reduce that simply, right? You learned that in grade 8. Now with variables, you can also do the simplifying as well, okay? Yeah, Eric is not coming today. Okay, and then part C is add and subtract, multiply and divide. So multiply and divide here. And then let's look at part D, right? Operations. Yeah, so part C is operation. Operation includes all the four multiplication, dividing, add and subtract. And then part D is solving equation. Equation is to find the x. So when we get to solving equations, then we can apply it to word problem. So that will be our final goal, right? So read the word problem, set up an equation and so forth. Okay, so all the equation we'll be dealing with will have fractions, right? So you look at all the equations as fractions. Right, so let's start with, I think in this book, right, book 2, the longest topic will be this one, right? So once we get through this, the rest will be easy, all right? So let's get to first page, okay, understanding what restriction is. So like I said before, restriction means something you cannot do, right? For example, when you are driving, right? If you are driving, well, of course, you know, when you see the red light, right? You are restricted to cross, right? For your safety. So same with other restrictions, right? Like like alcohol, right? Buying alcohol, buying cigarettes, right? So those things, you get restriction. Going onto the airplane, and even like for right now, you have to wear a mask, right? Those are all restrictions, something you cannot do. So for this part, right, restrictions on the variable. Okay, let me highlight that. So when we are talking about restrictions, it's talking about restriction of the variable. Variable means it can be many values, right? So when we say restriction on the variable, we are asking what values we cannot use in the variable. Okay, so what this means is we are looking for what values can't what values can't we use for the variable? Okay, so for example, if I substitute 3, right? Because x is any values, right? X is the like a box, right? So if I say x equal to 3, would that be okay, right? Can x equal to 5, right? If x cannot equal to 7, then we say 7 is the restriction. Okay, we just say x cannot equal to 7. Okay, so if we look at the definition, right? If numerator and denominator are both polynomial, polynomial means it has x variables, x and y in there, then it is a rational expression. And restrictions means they are the values that will make the expression undefined. Okay, so here's another keyword. How do you make a fraction undefined? Does anybody know? What kind of, anyone can answer. Brennan, what do you think? Yeah, who said that? Can you say again?
I did.
Yeah, Aaron, what did you say?
When you have a 0 at the bottom.
Yes, very good. Okay, so undefined is when the denominator, right? Denominator equals to 0, then it's not good, right? You cannot divide by 0, and the reason why is it's like when you divide something, you are sharing, right? It's like you have. Let me make a quick example, okay? Because a lot of people just know you cannot divide by 0, but don't know why it doesn't make sense. So for example, we have 10 chocolates. Okay, you divide by 2 people. All right, so you get 5, right? So 5 means you have 5 chocolate, right, per. So when you are dividing, you're asking how many chocolate for each one, right? Each person. But now if I change the value to 0, I want to share chocolate with no one, right? I want to divide 10 chocolate. You have 10 chocolate there. You want to divide it into no one there. How many chocolate does each one get? Right? So this answer won't be possible because there's not even a person there to receive the chocolate. So this one will be impossible, right? Does it make sense to ask this kind of question, right? So this is one of the way to understand why you cannot divide by 0, okay? So therefore, making the denominator 0 will be finding the restriction, right? So we're looking for what kind of value. If we sub it in to the variable, it will make the denominator equal 0. Okay? So now you understand what restriction means. We'll look at the first one. So our goal is to focus on the denominator, right? So the denominator, first thing you identify parts are. Parts are separated by multiplying, okay? So let me write that down, this is important. Okay, parts are separated by multiplying. Okay, please copy that down first, and then I'll explain. Okay, can you raise your hand if you finished writing? Okay, Nathan, almost done copying down the, yeah, okay. So what that means is when we look at the denominator, right, you have 10 times x cubed times y times z squared, right? So they are multiplying at the bottom. At the bottom, we have 4 parts, okay? So the idea is if you multiply by a 0, it will make the whole denominator equal to 0, right? If any of the part becomes 0, then they multiply equal to 0. And our restriction is we cannot have 0 in the denominator, which means we cannot have any of the parts equal to 0. Does that make sense? Okay, we need to make sure each of the part doesn't equal to 0. Otherwise, it will be undefined. Okay, so for example, we'll look at one part at a time, right? This is our first question. We'll spend more time on it. So the first part is the 10, right? It's a constant. It's not a variable, right? Constant. So it will always okay, constant. Oops. Okay, I think it's lagging today. Okay, let me turn on the program one more time. Okay, can all of you see the screen? Can you raise your hand if you can see the screen now? Okay, Aaron and Nathan, yeah, okay. Still a bit lagging. Okay, I hope this doesn't crash it again. Okay. Okay, so let's try one more time, right? So this one is a constant. Okay, good. So if it's a constant, it's never going to be equal to 0, right? 10 is just stay 10 all the time. But then for the second part, the x cubed, right? It's a variable, so it can be any number you want, but it cannot be 0, right? Because if x equal to 0, then everything multiplying by 0, it will make the whole denominator become 0, which is undefined. Okay, so we will say the restriction is x cannot be 0, right? Even with a cube, right? 0 to the cube is still gonna be 0, and it will make the whole thing equal to 0. So same thing, next part is a variable, so I cannot have variable equal to 0. Makes it undefined. Similar, right? Z cannot be 0. So for this question, even though we have 4 parts, but you only have 3 restrictions, right? Because 10 is a constant. Okay, does that make sense? Can you raise your hand if you understand how we get a restriction here? Okay, Nathan, do you have any questions? Yeah, good. Okay, so next part, so you can box that, right? If question only asks for restrictions, and just write the restriction down. Okay, so remember this sentence, parts are separated by multiplying. So let's look at B. So what do you think for this denominator? How many parts are there? Brennan? Denominator.
2 parts.
2 parts? Which 2 parts?
3x and x plus 1.
Okay, so remember the parts are separated by multiplying. So do you still think 2 parts?
Oh, wait, no, 3. 3 and then x plus 1.
Yes, very good. Okay, so remember multiplying, right? 3 times x plus 1. So x plus 1 count as 1 part, right? Because it's separated by adding, so they are together as 1, right? So when you're considering the restrictions, you need to identify how many parts there are first. But for this one, once again, the 3 we don't count, right? Because it's a constant. So for restriction, you just need to worry about the x cannot be 0, right? Otherwise, multiply by that makes the whole denominator 0. And also the third part cannot be 0, right? So, but then restriction is talking about restriction on the variable. So for this one, we need to do one more thing. Okay, we need to isolate the x. You just isolate the way you solve an equation, same way. The only difference is you have not equal to, right? So you move the 1 over, and get x cannot equal to -1. Okay, so those are the two values you cannot use in the variable, right? If I substitute -1 into the x, it will make the third part become 0, and that's not good. Okay, so we have two restrictions here. So sometimes restriction cannot be 0, sometimes restriction cannot be in other number, right? It's not always 0. Okay, so let's look at, let me have you try a few questions first, and then we'll talk about the third one, okay? So please do question A and B at the bottom, okay? I'll let you try these two, write out all the restrictions and raise your hand. We'll check those two questions before we look at C. So first step, identify how many parts. Second step, you look at each part and make them not equal to 0. And if the part has more than one term, then you isolate the variable. Another way to understand parts is you think about factors, right? Because you just finished learning factors. So parts can also replaced by this word, okay, factors. So by multiplying as well, right, factors. So question A, right, it has 4 factors. Question B has also four factors. Okay, please raise your hand if you finished restriction for question 1, A and B. Okay, so let's start with question A first. Okay, we'll check answer. Colin, how many parts in the denominator? Colin, are you there?
I said 3.
Oh, three parts. Which 3?
Yeah. X, y, and x minus 3.
X, y, x minus 3. Is that what you said?
Does 7 count as 1?
Yes, okay, 7 also count as 1 because 7 and x, they are multiplying, okay? So remember, rule is parts are separated by multiplying, okay? So count as 4 parts. But then 7, of course, you don't need to include restriction, okay? 7 is gonna stay 7, it won't become 0. All right, let's check the restrictions now. Okay, Yosher, what are the restrictions?
X cannot equal to 0, 3, and then y cannot equal to 0.
Okay, 3, y cannot equal to 0. Yeah, okay, for the x, you get restriction from 2 parts, right? You can get it from the second part, you get it from the last part, okay? X minus 3 cannot be 0, then that will give you the x cannot equal to 3. This one give you the 0, this one give you the 0. Okay, so your answer, you can write it like this, okay, in the red box. Okay, Nathan, what about the question B? How many parts are there?
Is there 2 parts?
Which 2 parts?
Like 2x take away 1 and then x plus 3?
Yeah, very good. Okay, so we just make each one and equal to 0. First part cannot be 0. Second part cannot be 0. And from each part, you can isolate the x. Okay, so Aaron, what do you have?
X cannot equal to 1/2 or -3.
Okay. Okay, so that's it. So that's your restriction. Okay, so you cannot use those value and then sub it into the question. Because if you do that, it will make the whole answer, right? If you substitute any of the 2 restriction, then your result, it will be something over 0, right? Some value on the top and then over 0, and that is not allowed, okay? Restriction. Okay, let's look at C, okay? If you look at question C and compare with A and B, what's the biggest difference that you noticed? Brennan, what do you see? What's the difference?
There are 2 polynomials.
There are 2 polynomial. What do you mean by that?
Well, there's 2x minus y, and then there's 3x squared minus 9y.
Yeah, so you mean we have 2 parts?
And there's like 2 variables.
Or 2 variable, yes, okay. The biggest difference will be the 2 variable. Question A and B, you only see, well, you see more than 1 variables, right? And then, but then question C is inside the part, okay? I think to be more precise, each part has 2 variables, right? This one clearly has 2 parts, but the inside the part, you have more than 1 variable. If you look at other 2, each part, right, even though we have 3 variable in question A, but then each part only has 1 variable, okay? Question B as well, right? You have 3 parts and each part has only 1 variable. So let's take a look, okay? So if you have 2 variables, one that comes first in terms of the order of alphabet, right? So if you have X and Y, you isolate the X. If you have P and Q, you would isolate P, right? Because P comes before Q, okay? M, N, you isolate M. A, B, you isolate A, okay? I think you get that. So 2 parts, right? 2x minus y cannot be 0. Second part will be 3x squared minus 9y cannot be 0. And then from each, we'll isolate the x. Okay, so I'll let you guys try these 2 first and raise your hand after you isolate x. So your restriction will have y inside. It will it will have a variable in your restrictions. Okay, please raise your hand if you got your restrictions. Okay, Colin, can you tell us your first one?
Y over 2.
Yep, very well over 2. Okay, move the y over. Right, and then divide both sides by 2. Okay, just the same way you would solve for a normal equation, okay, with only one variable. So cannot be y over 2. Anyone having trouble with the second one? Still working on it? Okay, Brendan, can you tell us your second restrictions?
I'm not done yet.
Okay, how about Aaron?
Is it root 3y?
Root 3y, like this? Is y inside or outside?
Yeah.
Huh? Is your y inside or outside?
Inside.
Inside the square root, okay. Anyone else got different? Does everyone got the same? Then you got 50% right. What are we missing? What's missing here? We talked about this before, okay, quite a while ago when we learned.
The plus minus.
Yes, very good, okay. So you isolate the x, right? 3x squared, move the 9y over, cannot be 9y. Divide both sides by 3. That makes it 3y, right? That part, no problem. But remember when we learn quadratic equation, when there's one variable, right? Solve by isolate. You need to put plus minus the moment you put the square root, right? If you are the one square rooting it, then you need plus minus. Okay, so please don't forget that. Okay, Brennan and Nathan, do you have any questions?
No, I'm done now.
Okay, understand? Okay, so don't forget plus minus. So let's just try question C at the bottom now. Okay, so everyone work on that. And you can raise your hand when you finish question C. So similar, it has two variables inside each part. So you have x and y, so you would isolate the x. Please raise your hand if you finished. Okay, let's check the answers. Colin, what's your first restrictions?
Negative 2y.
Okay. And Brendan, what's your second restrictions?
2x.
2x.
Yeah.
X cannot equal to 2x.
Oh, wait. Oh, wait, no, it's negative x over 2, sorry.
X cannot equal to negative 2x over 2. Is that what you said?
Wait, which question are we doing?
Question C.
So we're seeing all x values that,
Yeah, we're finding
oh,
restriction for the X.
okay, 3y over 2.
Okay, let me write it down. Okay. Give me 1 sec. Okay. You said 3y over 2, like that? Yeah? Okay. Anything else? Is that all? Okay.
And
Yeah.
negative 3y over 2.
Negative 3y over 2. So total 3 restrictions. Any other restrictions? Did anyone miss anything? Okay, Nathan, do you have any questions? How to get the restriction here?
No, I don't have any questions.
Okay, all right, so I'll just quickly write down the steps here. Okay, x plus 2y cannot be 0. So isolate x cannot be negative 2y, right? Same thing with this one. If you isolate the x, you would move the 9y squared to the other side. Divide by 4. And when you square root, right, remember you need to put plus minus. So square will be gone. You put square root on the whole thing, put plus minus. And then the square root will cancel out the square on the inside, and square root the 9, square root the 2, give you the 3 and 2. Okay, so that will give those 2. So total you have 3 restrictions. Okay, so of course you can list one line, right? X cannot equal to negative 2y, comma, right? 3y over 2, right? Comma, negative 3y over 2. Okay? So now you all understand what restriction means. From now on, right, all your, later on when we do adding, subtracting, right, of the expressions, right, you have to include restrictions. Whenever you see the denominator has variables, you need to write restriction. Even though the question doesn't ask for that, okay, you still have to write it. So similar, like, let me show you what a homework will look like, okay? So something like this. So here it says, each of the following state any restrictions, right? So it's talking about like everything on this whole page, right? And then same with this one, right? In each of the following, state any restriction, even though the question asks you to simplify. So after you simplify, you still need to write the restrictions. Okay, it's part of the solutions. All right, so the answer will have two parts, simplifying and restriction. Okay, so what does simplifying mean? That's what we're going to do. All right, so let's go back to page 39. So simplify fractions, simplify rational expression. Okay, you will do that when there is a single fraction, right? One fractions. Then it can simplify by using factor and exponent laws. Okay, factoring, we just learned it. We just finished factoring. Exponent law is just very simple exponent laws that you need to, for example, let's write it on the side, okay, before we begin. If I have 5 to the, let me write it down, to the 4 times it by 5 to the 3. What can we do? Does anybody remember? How do we simplify this one? 5 to the 4th
I'm
times
pretty
5.
sure.
Yeah? Nathan?
Jason, do you like you just add the exponents?
Yeah, you would just add an exponent so it becomes
5 to the power of 7.
yeah, 5 to the 7. So it's just counting how many 5s they are multiplying, right? 5 to the 4 means there are 4 5s, and then you have 3 more 5s, so total you get 7 5s. So same thing with variables, right? You can do the same thing if it's x. X to the 4 times x to the 3 will just equal to x to the 7. So that's the first rule that we need. Second rule that we also will be using is dividing. So let's say if I have x to the 7 divide by x to the 2, then dividing you can reduce it, right? Divide it away, so it's subtract instead, x to the 5. But then sometimes it will be the opposite, right? The lower one has more. So if you get something like this one, let's say y, okay, let me write it out again. Okay, y to the 2, y to the 7. Now this time the denominator has more y's. How do we simplify this one now? The result, how do we write it? I cannot write y to the 5, right? What do we do? Anyone? Aaron, what do you think? What will be the answer look like?
1 over y to the power 5.
Yeah, okay. So you will need to have a 1 on the top. Okay. Because it's reducing, it's dividing. Okay, so think about if I have 2 over 10. When you do the dividing, right? The 2. Oops. Right, divide top by 2, it will become 1. Divide the bottom by 2, it will become 5. So you write it as 1 over 5 instead of just 5. So same with the variable, right? You would divide both top and bottom by y squared. Divide by y squared. So that will give you 1 on the top and y to the 5 at the denominator. Okay? So keep those two in mind, right? One is the multiplying rule, one is the dividing rule when we are doing simplifying. I think we will have a break first, okay? An earlier break, so we can start this page, okay, without the break interrupting. So let's start the break now, and then I'll see you guys at 11:10, okay? So 10 after 11.